Today we are going to learn about prisms, their total surface area and their volume. So prism can be defined as a three-dimensional shape with identical faces at both ends, and the area of cross section are the same throughout its length. You could best identify prism with the example of a loaf of bread. When a loaf of bread is usually cuboidal shape, like if you slice it up, if you slice up the loaf of bread, then you will find the same area of bread. And that is what prisms are. Same area of cross section throughout the length of the prism. Prisms can be of different types, and they are named based on the bases, based on the cross-sectional area, they have. For example, this prism here, its cross-sectional area is triangular in shape, so it's called a triangular prism, and this cross-sectional area is the same throughout this length. Throughout this length, the cross-sectional area is the same, and that is why it's called a prism, and its name is a triangular prism. It's a hexagonal prism because the cross-sectional area is shaped like a hexagon. That's why it's called a hexagonal prism. And if you slice up this prism, you would get hexagon. A cylinder, you all have seen cylinders, I think so. A cylindrical shape can also be called as prisms, because if you slice up this, you would get circles, and all the circles you would get would have the same area. So a prism with circular area of cross section is called a cylinder. This is a cuboid. It has cuboids have rectangular or square shaped rectangular shaped cross section, and just like before, I have given the example of a loaf of bread. You would get this same shape throughout its length. For cube, it's also the cross-sectional area is square shaped, and the cross section, the length of the cross section, the length of one side of this square, let's say it's A, it will also be A, and the prism length would also be A. That's what makes it cuboid. Sorry, this one is cuboid and this is cube. Cuboid, this length could be rectangular or square, but this length will not be the same as these lengths. That's why it's called a cuboid. But for cube, the length in 3 dimensions are the same. That's why it's called a cube. You have seen cubic shapes, like when we roll a dice, the die is a cube. So now let's learn about how to find the volume of prisms. For the triangular prism, easily said, it can be said that a volume of prism is the cross section, is its cross sectional area multiplied by length of the prism. So for triangular prism, the volume would be the area of this triangular face, area of this cross section multiplied by the length. For hexagonal prism, the volume would be area of this hexagon multiplied by length, For cylinder, you need the area of this circle. For cylinder, the prism have a circular cross section. So you need the area of this circle and the length of the cylinder. So for that means volume of cylinder V equals to pi r square into L. You see, pi r square is the area of the circle. Pi r square is the cross sectional area. For cuboid, let's say this is the breadth of the rectangle, breadth, width and height, or let's just denote it by L. This side is of length B, this side is of length W, and this whole length is L. So for cuboid, the cross sectional area is B into W into L. So the volume would be B into W into L. For cube, the cross sectional area is A square, the length of the prism is A, so A square into A cube. That gives us V equals to A cube. Now to find the total surface area of prisms, you need to find the area of all the faces of the prism. Like in this triangular prism, there are 1, 2, 3, 4, 5 face. 3. There are 5 faces of this prism. So you need to find all the 5 area. This face and the face at the back, the triangular shape, so they would have the same area. So cross sectional area multiplied by 2 multiplied by these 3 rectangles. If you have anything shaped like this triangular prism, you would observe that these 2 faces would be of rectangular. 3 faces are of rectangular shape. The faces at the sides are of rectangular shape. Same for hexagonal prism. You need the area of hexagon both at the front and the back, and these 2 areas are the same. So area of hexagon plus area of hexagon plus there would be 6 faces of rectangle. So you need area of those 6 rectangles. To get the surface area of cylinder, total surface area, you know this area is pi r square. At the back, this is also pi r square. And if you make cylinder by rolling a paper like this, you would see that if you cut it in a straight line, you would get a rectangular paper. So after cutting the cylinder in a straight line, like here, like let's say if you are cutting the cylinder in this position, if you spread it, you would get a rectangular paper like this, where the length of this is equal to the circumference of the cylinder, and you know circumference of the circle, circumference of circle is 2 pi r, and you know this length is L. Sorry, my proportion is not right. Let's say this length is L. So you would get area of cylinder, total surface area of cylinder equals to 2 pi r L plus the two circles at the front and the back, 2 pi r L plus 2 pi r square, because one circle have an area of pi square, so two circles would have an area of 2 pi r square. For cuboid here, total surface area would be 2bw. B into W is one cross section, one face, B into W, 2bw plus there are 4 faces, right? Area equals to 2bw plus 2wl, because this the area of this face and the area of this face is the same. This is also W. That's why I wrote WL plus WL, 2WL plus BL, 2BL. This face have an area of BL, and the face at the back has also an area of BL. And the area of this cube, all the 6 faces of this cube are of same area. So that makes one face have an area of A square, and there are 6 faces, so area of cube equals to 6A square. You might have noticed by now that we can also write the area of prisms like perimeter of the cross sectional shape multiplied by its length. Like let's say let's give this as an example. Its perimeter, the perimeter of this rectangular shape is B plus W. Multiplied by length. That means we got the 2b, right? 2b plus 2w, perimeter of this rectangle. The perimeter of this rectangle is 2b, because b plus b plus W plus W, 2B plus 2W into L plus area of the cross section, which would be BW. The cross section are at both ends, that's why 2 into BW. So we can also write area of prism as the perimeter of the cross sectional face into length, the length of the prism plus the area of the cross section at both ends. Now we will do one exercise on finding the volume and area of prism. Here it's a triangular prism. It's a right angle triangle, as there's a sign which indicates that it's 90 degree, and BFC is a triangle, so the angle BCF is 90 degree. That's what makes BFC a right angle triangle. So to find the volume of this prism, we need to find the cross sectional area of this triangle and the length. The length is already given, it's 60 centimeter, and now we need to find the area of BCF, the triangle BCF. So to find the area of this triangle, we already know the BC, and then now we need to know the length FC. To find FC, we can use the sine rule. We can write sine 30 divided by FC equals to this angle, which would be the total internal angle of a triangle is 180 degree. So 180 minus 90 minus 30 gives us 60 degree. So the angle BFC is 60 degree. We get this by 180 minus 90 minus 30. So we write sine 60 divided by 60. Now we get FC equals to 60 sine 30, 60 sine 30 by sine 60. This gives us 20 root 3. 20 root 3 centimeter. So now that we know two sides of this triangle, we can find its area. That means the area of cross section of this prism. So the volume of this prism would be half into 60 into 20 root 3 multiplied by its length, this length 60. That gives us volume equals to 62,353.8 cm cube, centimeter cube. Now that we have found the volume of this prism, we are going to find the total surface area of this prism. So this prism have 2 triangular faces and 3 rectangular faces. Sorry, this face is a square, as it states that ABCD is a square. ABCD is a square, but ABFE is a rectangle. That means DCFE is also a rectangle. So we can find the area of to find the total surface area. Total surface area equals to area of ABCD plus area of ABFE I'm just writing ABFE plus area of DEFC plus the cross-sectional area of the prism multiplied by 2, because the triangular face are at both ends. That gives us 2 into the area we wrote here, 2 into half into 60 into 20 root 3. Area of ABCD, we know the length AB, it's 60, BC is 60. So area of ABCD is 60 multiplied by 60 plus ABFE. So it's already written that here that ABFE is a rectangle. So that means the angle ABF is 90 degree, BFE is 90 degree, also FEA and EAB. So the area of the rectangle ABFE would be 60 multiplied by this length, the length BF. So the length BF is root over of length of BF, length of the side BF equals to root over FC square plus BC square. BC is 60, so 60 square plus FC square. FC square, we got FC square, FC as 20 root 3. 20 root 3 equals to 40 root 3. So the length of this is 40 root 3. So ABFE, area of ABFE is 40 root 3 multiplied by 60 plus DEFC. DE have the same length as FC, so that would be 20 root 3 multiplied by 60. Plus from here, if we use a calculator to find the area, we would get 11,913.84 centimeters square. Yeah, that's all for today about prisms.